In this demo, we'll apply two static methods on the string type to concatenate some data. We'll implement a new report writer, which uses string.join to join a sequence of strings together with a common joining character. We'll then apply string.concat to append the data to an existing string. The business leadership has come to us with a new requirement. They would like us to produce a CSV file of the valid and normalized sales data. Each row should contain a record with comma-separated values. We'll begin by adding a method on the historical sales data type that returns formatted strings for each piece of data that we need to include in our report. Our method will return a string array. We'll name it getFormatedComponents. It should accept a culture info to allow us to perform culture-aware formatting. The first string will be the date of the sale, formatted as a universal sortable date-time string. The universal format is culture agnostic, but we'll pass in the culture info nonetheless as a safety measure should the format ever be adjusted. Next, we'll add the strings for the product sales code, product SKU, product name, category code, and currency into the array. For the unit price, which is defined as a decimal in our model, we'll format it using toString. Just like dates, we can format numeric values by providing a format specifier to the toString method. For the unit price, we'd like to format this with decimal digits. We can use the number format specifier, the letter N, followed by a precision specifier. The precision specifier controls the desired number of decimal places. We'll use 2 for the price data. Using this number format specifier will also include thousand separators between groups of digits. We'll pass in the culture info to ensure that the price is formatted with the correct cultural rules applied. This ensures that the correct separators will then be used based on the application culture. For the quantity and sales tax percentage, which are modelled as a long and integer respectively, we want these to include thousand separators for large values, so we'll use the N number format specifier. We'll format these with no decimal places, using 0 for the precision specifier value. This completes our work on this method. Let's visit the partially complete sales data writer, which we'll complete in this clip to meet our requirement. We'll use some static methods of the string type to achieve this. Once again, I want to remind you that we won't be using the most optimal and recommended way to produce large strings. This is another demoware example to show how these methods can be applied. We'll implement a better solution for building strings in the final module. With that caveat out of the way, let's get started. We define a variable for our string and start by assigning the empty string value. We can then loop over the data to build up the report string. To create a row, we can utilize the join method. Join accepts a character to use as the separator and an array of values to be joined. We want our data to be comma separated, so we'll use the comma character when joining. To supply the elements that will be joined, we can call our new method getFormatedComponents. We'll pass in the application culture from the options. Once we have a joined row, we'll combine it with the new line character. Of course, we could use the plus operator here, but we can also call the concat method directly. As well as an overload accepting an array, overloads exist which accept 2, 3, or 4 string values. This approach avoids the array allocation in those simple cases. We'll pass in the row and a new line as the 2 string arguments. The result is then appended to the formatted output. The final step for this method is to iterate over the output writers and write to each of them in turn. We'll use the writeDataAsync method, which is asynchronous, and pass in the formatted output, the path in the file name, and the cancellation token. We need to register our new report writer in the sales data class. We'll create an instance and then invoke its writeAsync method. We'll provide a file name for the processed data. I'll run the application so that we can produce the new report. This time, I'll open the file from my configured output directory. We have a CSV file of sales data, reformatted and normalized to meet our requirement.